Hello, algebra students. Today we are going to try a different way of solving systems. We're going to solve them by graphing. Remember, we've talked about in previous videos that we're finding the place where the lines cross. Now, in some story problems, this can be a very, very important piece of information. But we're not going to get to the story problems just yet. We're just going to solve systems by graphing. Now, I got to warn you, this can be an inefficient way to solve a system, and you'll see why in a minute. We're going to do problems where it's a great way to do it, and then we're going to do one where it might not be so good. So let's go ahead and graph this blue equation. It looks like y is going to y equals 3x plus 1. I'm in slope-intercept form. I'll put a point at the y-intercept, and I'll rise 3 and run 1. Rise 3, run 1. Okay, and so I can draw my line, and it's going to go through those points. Now I expect you totally to already be a master of this. If you uh, are not a master of slope-intercept form, you need to come in for help, and I will just give you problem until you are a master of it. It is not acceptable for you to leave my class not being able to graph an equation in slope-intercept form. All right, here's the second equation. The y-intercept looks like it's 9. Slope is negative 5. 1, 2, 3, 4, 5, and run 1. And then 1, 2, 3, 4, 5, and run 1. And then I think you're a coward. All right, so here we go. Um, the place where the two lines cross is pretty obvious that it's at 1, 1, 2, 3, 4. So they intersect at 1, 4. If I go ahead and use substitution or elimination on this equation, you'll see I'll get 1, 4. I mean, I can prove it really quick. Multiply the bottom equation by negative 1. Add them together. Get 0 equals 8x minus 8. Add 8 to both sides. And I'll get 8x equals 8. And therefore x does equal 1, just like we claimed. If I plug that into one of these equations, I'll get 3 times 1 plus 1, which ends up being 4, doesn't it? Yeah. All right, so some of you are thinking, wow, I'm always going to do it by graphing. Well, just hold on. Let's look at a second example here. We've got an equation in standard form, so I'm going to find my x-intercept by making y 0. I believe that'll occur at 2. Find my y-intercept by making x 0. Looks like that'll be at negative 3. Looks like my slope is 1, 2, 3, 1, 2. My slope is rise 3, run 2, rise 3, run 2. And so I can draw my blue line. No, I would hate to. Sorry about that. Didn't realize the recorder was still going there. So there's that line. Okay. So let's do the red line. Looks like the y-intercept is at negative 5. So that was negative 3, 4, 5 right there. The slope is rise 1, run 2. Rise 1, run 2. Like that. And it looks pretty obvious, like the two lines are going to cross right here. So the solution is going to be at what? Negative 2, and then 1, 2, 3, 4, 5, 6, negative 6. All right, so that's how we solve by graphing. Now, we can solve this one by graphing, only it's not going to be so pretty. We'll do the first one, y-intercept of 3, 1, 2, 3. And then we're going to go down to 1, 2, 3, 4, 5. Of course, we can go back to 1, 2, 3, 4, 5. All right. Okay, y-intercept of 1. And there we go. Now you can tell clearly that they intersect here, but you don't know the x-coordinate nor the y-coordinate of the point of intersection. You might be able to guesstimate it. You might be able to say, well, let me drop it down here, and oh, that line's pretty big and bulky. Let me make it a nice thin line. Okay, so let me get another line here, and before I put it on there, I'll make it nice and thin. Okay, so I can guesstimate, but some of you are thinking, well, x is 1.5. Well, how do you know it's 1.5? How do you know it's not 1.42156? You don't. Okay. If I actually solve it, and I'll solve this by substitution, you'll see I'm going to get some pretty strange x and y values. X plus 1. So I'm going to subtract 3 from both sides. And I'm going to subtract x from both sides, right? So I'm going to get negative 1 and 2/5 x equals negative 2. 1 and 2/5 is the same as negative 7/5 x, which is negative 2. And we're going to divide by negative 7/5, which is the same as multiplying by negative 5/7. All right, so I'm going to get negative 10/7, which is the same as x is going to equal negative 1 and 3/7, which, funny, I picked 0.42 because if you remember my trick, 14, 28, 57, this is actually going to be, oh, did I write 3/4? I should have written 3/7. They're silly me. Some of you are going, well, it's 1 3/4. Okay, there we go. This is actually going to be negative 1.428571, and then it repeats. So it's kind of funny that I picked 4.2 and got a 4.2 there. All right, but that's just coincidence. And then, of course, to get the y-coordinate, I would have to plug this into, it looks like the second equation might be really easy. And so I'm going to go y equals negative 1 and 3/7 plus 1, so therefore y will equal negative 3/7. So the point of intersection actually occurs at negative 1 and 3/7 and negative 3/7. Okay? There's no way you would guesstimate that. There's no way. You could get close, but there's no way you'd be able to accurately guesstimate that on this type of graph. So that's the downfall to solving systems by graphing. Now we will do some soon where graphing is a great way to solve it, and this point of intersection is exceptionally important. But for right now, just I wanted you to see the limitations of solving by graphing. All right, that's it for today's lesson. Mr. Lawrence signing off. Good night, everybody.